Hello, and today's learning target is I can solve and graph compound and absolute value inequalities. So let's remember that when multiplying or dividing by a negative, we must flip the inequality. So let's go ahead and we will solve and graph the following compound inequalities. Remember, compound means more than one. So with this first example, we see an or statement, and we'll talk about what the difference is between or and and statements in just a moment. You might remember really what the difference is between the two, but we will go over that here when we're done with the problem and then we'll see the differences between the two. So I'm going to solve both these inequalities separately. So I'll subtract 1 and get n is less than or equal to -4. And the second inequality, I'm going to divide by a -4. And when I divide by a negative, this is what we just wrote down, we must flip the inequality. So n is greater than 2. So here I get n is less than or equal to 4, or n is greater than 2. So what really should happen with or statements is we want this answer or that answer. So a lot of times, except for a few special cases, you will see that there's a gap in the graph. And one of the inequalities, when we graph that, will go one way, and when we graph the other inequality, it will typically go the other way. So as we graph this here, I'm going to go ahead and write down, let's put 0, 2, 4, -2, -4, -6. And now I'm going to graph n is less than or equal to -4, close circle going to the left, and then n is greater than 2, open circle at 2, shading to the right. So as you can see, there is a gap here in this graph. So how I write my answer is just n is less than or equal to -4, or n is greater than 2, and I'm telling my reader that, hey, you could have an answer here or here. It just can't be any of the numbers in the middle that doesn't have, not being shaded, because that's not part of our solution set. So let's move on here. And hopefully these will, you'll start to remember these, and you'll remember, oh yeah, this is the difference between or and statements. Or if not, here's just a quick little brief overview. So x plus 8 is greater than or equal to 9, and x divided by 7 is less than or equal to 1. So when I see an and statement, this is obviously different than an or statement, but what I hope to see within my answer is I hope to see an overlap. I hope to see, hey, the answer fit in this first inequality and it fit in the second, and here's what was the overlap, where the two had, shared answers. So let's go ahead and let's solve both of these two inequalities separate again as well. I'll subtract 8, get x is greater than or equal to 1, and then multiply by 7, and get x is less than or equal to 7. So I have x is greater than or equal to 1, and x is less than or equal to 7. So if you can visualize, if it's greater, my answer is greater than 1, but less than 7. That's going to definitely be an overlap. So I'm going to go ahead and just jot down a few numbers on the number line here. And I have, and we can visualize this, x is greater than or equal to 1, so I'll use green. And then x is less than or equal to 7, so less than 7 but greater than 1, definitely there's an overlap. So how I write my solution set or my answer is I write one variable, the lower number on the left, higher number on the right, and this is again only for an and statement, and x is greater than or equal to 1 but less than or equal to 7. And if I wrote this correctly, my inequalities should also be pointing the same way, which they are. So there's my solution set to match my graph. All right, let's continue on to the next example. Okay, so I have an or statement, so hopefully I'm seeing a gap here. So what I have is two inequalities that I need to solve. And I'll go ahead and solve this first one, and I will add 8 to both sides. I get negative 5b is less than or equal to negative 60 divided by negative 5. B is greater than or equal to 12. Let's fix that. There we go. Second inequality, I'll go ahead here and add 12. And I get 11b is less than negative 88. Divide by 11. B is less than negative 8. So here I have something that's greater than 12, but less than negative 8. So this definitely will be a gap in the graph and an OR statement. So I'll go ahead, make my number line appropriate here, go up by 4s. And I have B is greater than equal to 12, filled in circle going to the right, and less than negative 8, so an open circle shading to the left. So this inequality that we see here, this is one long inequality that I'm going to break up into two. So this would be the first case, and this would be the second case. So as I solve this first case, I'm going to rewrite this over to the side. This actually also is an and statement, right? We don't see the word or, we don't see the word and, but since they're connected, this is an and statement. So hopefully at the end we see an overlap. But if we don't, then this would be a special case, and we haven't gotten to any of the special cases quite yet, but we will certainly talk about those. So I'm going to subtract 11 and get 25 is less than or equal to negative 5x. Divide by a negative, so I flip the inequality. And then I'm actually going to rewrite this so my variable's on the left-hand side. So x is less than or equal to negative 5. We're going to just get rid of this inequality there. We're not going to go through that example. Okay. Over here with the second case, 11 minus 5x is less than or equal to 66. Subtract 11. 55, divide by negative 5. X is greater than or equal to negative 11. So here, as I make my graph, I go ahead and make a few points. And I have less than or equal to negative 5, but at the same time greater than or equal to negative 11, so this will be an overlap. As I write my solution set, I'm going to put x in the middle, negative 11 on the left because that's the smaller number, negative 5 on the right because that's the larger number, and then my inequalities should point the same way, again if I'm correct, and I am, so negative 11 is less than or equal to x, which is less than or equal to negative 5. Okay, now let's take a look at absolute value inequalities. So remember, when solving absolute value inequalities, we must split into two inequalities, and we'll flip the inequality sign, on the number. Okay, so we'll flip the inequality and the sign on the number when we make our second case. So, and something to remember, only split the inequality when it has been isolated. So not necessarily new, but just another concept we're going to add in to make sure that we have understood with absolute value inequalities. All right, now we will solve and graph the following inequalities. So I have the absolute value of 10 plus 4x is less than 14. So I'm going to break this up into two inequalities. One is exactly how I see it, and the other will change here in a moment. So 10 plus 4x is less than 14. The second case is 10 plus 4x is greater than negative 14. Okay, so I'll go ahead and solve this first one, and I'm going to subtract 10 4x is less than 4, divided by 4, x is less than 1. Now my second case, I'll subtract 10. Divide by 4. So now I have for my solution set, my solution that will be less than 1 but greater than -6. So as I graph that, maybe you can already tell this will be an and statement because I will have an overlap. So I will put an open circle at -6, open circle at 1, everything less than 1, but greater than -6. So I'll go ahead and write my solution set, and I'll put x in the middle, 1 on the left, or -6 on the left-hand side, 1 on the right-hand side, and x is less than 1, but greater than -6. All right, let's take a look at the second example. All right, so let's break this into two cases. So -9v is less than or equal to 54, and -9v is greater than or equal to -54. Right, so now I have to flip the sign, inequality sign, and change the sign of the number. So as I solve this first example, I'll divide by -9. V is greater than or equal to -6. Divide by -9. V is less than or equal to 6. So I'll go ahead and graph this, and if I have something that's greater than or equal to -6 but less than 6, I will have an overlap, and this will also be an and statement. So close circles on both, and then I will rewrite this with my variable in the middle, and my lower number on the left, higher number on the right, and that is my final answer. Let's go ahead and go through the example here in the upper right. We're going to skip that first one on the left. Don't think we need more practice with that one right now. And I'm going to Okay, before I can write my two cases, I first have to isolate the absolute value. So I need to move this 3 to the other side before I can write my two cases. So I get n minus 2 is greater than 8. Now I can go ahead and write my two cases. So the first one is n minus 2 is greater than 8, and the second case is n minus 2 is less than -8. Now I'll go ahead and I'll solve both of these. N is greater than 10, and I get n is less than -6. So I have n is greater than 10 and n is less than -6. This will, I'll go ahead and number my number line first. This will be an or statement because there will be no overlap. So I have n is greater than 10, that's an open circle, and n is less than -6, open circle shading to the left, so I'll just write my solution set with the word or in between. N is greater than 10 or n is less than -6. Okay, and we have one last example here. We're going to end with a compound inequality, so we're going to go backwards here. In this example, I wanted to talk about, because it is important, we haven't discussed any special cases yet, so giving a little hint at what we'll see. So let's go ahead and solve this compound inequality, and this is an and statement because we see the word and in it. So I'm going to go ahead and solve both inequalities here. So I'll go ahead and subtract 4a. 8 is greater than 7a plus 15. Subtract 15. -7 is greater than 7a divided by 7. -1 is greater than a, or if we reverse that, a is less than -1. Okay, now for the second inequality, I'm going to add 14a to both sides and get 13 is less than or equal to 13 plus 11a. Subtract 13. 0 is less than or equal to 11a. Divide by 11, but that doesn't matter because 0 divided by any number is 0. So 0 is less than or equal to a, or a is greater than or equal to 0. So if I were to graph this here, -2, -1, 0, 1, 2, I would have an open circle at -1 shading to the left, and a closed circle at 0 shading to the right. But this was an and statement, but we don't have an overlap. So there's nothing that the two inequalities share in common, so this is actually a no solution, right? Because again of the and statement, and there was not an overlap, so no solution, and actually then we would have an empty graph because that would represent not having a solution. Thanks for listening. Have a great day. Bye-bye.